Checking division with multiplication using inverse operations. Because multiplication and division are inverse operations, you can check your division using multiplication. You learned this in primary grades with fact families. You learned that because you know that 2 plus 3 equals 5, that 5 minus 3 equals 2, because this operation is an inverse of this one. Therefore, you could use addition to check this subtraction. If I wanted to know if 10 minus 8 was equal to 2, I could simply add the 2 to the 8, and if they do equal 10, I know that this operation was correct. So in third grade, I know you learned this in relation to multiplication and division with basic facts. So let's push on to fifth grade standards. We're going to level up here with this division, 475 divided by 25. And we're going to work it in the partial quotients strategy. So please work with me on your desk. All right, let's set that up. We want our dividend, 475, inside the bracket, and our divisor, 25, to the left. All right, I'm going to work with friendly multiples of 25. I'm first going to multiply by 10, because I know that 25 times 10, I can mental math it to get 250. That's a pretty sizable chunk of 475. When I subtract, I have 225. I can't use 10 again as a friendly multiple, but I can use half of 10, which is 5. If I multiply 25 times 5, I'm going to get 125. When I subtract, I see that I have 100. And because I know 4 quarters make $1, I know that 25 times 4 is going to give me 100. And I can zero that out. Okay, so here I can see my quotient is, when I add 10 plus 5 plus 4, my quotient is 19. And I'm going to double check that using multiplication. And what that means is I am going to multiply my quotient times my divisor, and this should give me the dividend. So let's give it a try. Set up the problem, 25 times 19. We'll pause the video while you multiply. Okay, let's check that together. 9 times 5 is 45. 9 times 2 is 18, plus 4 is 22, so we have 225. And you might notice that this matches this right here. All right, I'm done with that 4, and I'm done with that 9, and I need my 0 placeholder. Now I'm multiplying by 1, so 1 times 5 is 5. 1 times 2 is 2. And you might notice that this 250 matches this little portion here. All right, and I'm going to add these together to get my final product, 5, 7, 4. So when I add, you can see I'm successful here. My product is equal to my dividend. And so that tells us that 19 is the correct quotient. All right, we're going to move on to another problem. Okay, this one I've worked for you. And so try this one on your own. Use multiplication, multiplying the quotient 96 by the divisor 7 to determine whether 96 is an accurate quotient for 672 divided by 7. Okay, so that worked out. Now, what happens when there's a remainder? Well, we simply have a different strategy for checking. We're going to multiply the quotient by the divisor, as always, and then we're going to add the remainder. So here I've worked the problem for you. 2,794 divided by 16, and I got a quotient of 174 with a remainder of 10. And we're going to use the standard algorithm here to determine whether this is accurate. Now remember, after you multiply the quotient by the divisor, don't forget to add the remainder. So at the end, you're going to add this 10. All right, check my work to see if it's accurate. Okay, let's try another. Are these calculations accurate? I have found that if I divide 941 by 33, I get a quotient of 29 and a remainder of 24. And so to check for accuracy, I'm going to use this expression. I'm going to multiply my quotient 29 by my divisor 33, and then when I get that product, I'm going to add my remainder 24. So here we go. Start with 29 times 33 and work from there. Let me know what you find out. Did you find the calculation error? If your product does not match your quotient, you need to rework your calculations.